That nomenclature. You guys have been working on nomenclature. You're feeling confident in nomenclature? Yeah? Yes, no, maybe?
Yeah.
Okay.
Yeah. Like 75%. 75. Same.
Okay. So ionic compounds. So what are some of the key features of ionic compounds?
They are binary.
They're binary. Yes, good job. And typically they have
no prefixes.
No prefixes, okay? So you're doing pretty good there. Also, they're composed of what type of elements?
Non-metals, metals.
Non-metals and metals, okay. Okay, so let's see. Let's say we have this guy. Okay, I'm gonna type something up. I want you to tell me if the name is correct. Is that the correct name?
No.
No.
No. What's wrong with it?
The prefix?
The Roman numeral.
Okay.
Because that's not a transitional metal.
Okay, so we know that that guy would be wrong because of
magnesium is 2+.
That's right. So we know that magnesium isn't a transitional metal, so we don't need the Roman numeral. And then somebody had mentioned the prefix. So we know that that is incorrect. So the correct name for this guy is what?
Magnesium chloride.
Magnesium chloride. Okay, let's see. Let's try another one. Okay, is that name correct?
No.
No. Would it be mercury hydroxide?
Okay, so would it be mercury hydroxide?
Would it be Roman numeral 1?
That is correct. So it would be mercury 1.
Hydroxide.
Oh, okay.
Okay, let's see. What about this guy?
So ammonia.
Is that name correct?
No.
Okay, what's wrong with it?
Would it be ammonium arsenate?
You said arsenate?
Arsenate, yeah.
Are you sure?
No. What's the one when it's 5? Is it hypo or is it per?
It's
Per.
Per arsenate.
Okay, so that's right. It would be ammonium. Ammonium per arsenate. Okay, meaning that we know that arsenate is AsPO4 3 minus. So if we add one more oxygen, it'll be per arsenate. Okay.
Yes. What did you say the bottom was? But the bottom one was, Dr. Henry, with the 4?
That's ammonium. Ammonium, not ammonia. Ammonia is NH3, right?
Oh yeah, and then with that's an oxygen. Okay.
And ammonium has a +1 charge, where ammonium is neutral, right? I mean, ammonia, neutral. Ammonium has a +1 charge. Ammonia is neutral. Okay? Questions, concerns, Cash?
No.
Good. Okay. So for covalent bonds, or covalent compounds, how do we name those?
Those only happen between nonmetals.
It only happens between nonmetals. That's right. So with this guy being is that correct?
No.
No, we know that this is not hyposulfite because hyposulfite is an ion. So, and this has no charge associated with it. So the correct name would be?
Sulfur dioxide.
Let's see. Okay. Oops. Is that correct?
No.
No.
No. They're not metals.
They're not metals and they're not transitional metals specifically, right? So then we know that the name of this would be what?
Dicarbon.
Bicarbon.
Pentanitrogen.
Trifluoride.
And trifluoride.
Okay. So what about this guy? Okay, so is this guy this?
No. Wouldn't it be? Would it be like N4?
The subscript go to 4O2F.
Ah,
4O2F2.
so I need to use subscripts.
Yeah.
Okay. Piece of cake.
Yes.
Okay. Let's see. Okay, let's see. All right, put up my that's the wrong one. Sorry, I'm pulling my examples here, make sure I'm not forgetting something to show you. Okay, so let's try this one here. Hydrates. Okay, so hydrates. So is that correct?
No. Silver carbonate.
Okay, so what's wrong with it?
You need the dot after CO3 to like separate the ionic compound from the hydrate.
Okay, so I need a dot, you said, like that.
And then it's going to be 5H2O.
5H2O. And is that the right chemical formula for silver carbonate?
Well, carbonate is...
Would it be Ag? It's Ag2CO3?
Ag2CO3, that's right. because we know that if it just says silver, just for silver, only for silver, that means it's silver 1.
Yeah.
Okay. What if you get this? Have you guys heard of this guy? Let's say silver carbonate anhydrous. I didn't talk about it, but I was wondering if anybody knew. Well, let me tell you what it means. Anhydrous, that "an" basically means without. So this guy means silver carbonate without water. So this is letting us know, because there are certain reactions that we do that if water's present, it can cause an explosion, right? So you want to sit there and let somebody know if you remove the water from that chemical. And so in this case, you're letting this individual know that, hey, it's silver carbonate. So the chemical formula would be Ag2CO3. And that would be it without any water. Okay. Does that make sense?
So only "and" means without water? Or
yeah. Well,
just...
anhydrous means without water. "And" means without. Hydrous means water.
Oh, okay.
Like anti-water, no water.
Oh, okay.
Okay. Let's see. Let's give you another one of these guys. What about this guy? Let's go. Oops. Can you guys see that? Let me slide it over a little bit. Is that correct?
No.
No.
Isn't that supposed to be?
Would it be magnesium instead of magnesium?
Manganese?
Yeah.
That's right. Manganese?
Instead of the magnesium, yeah.
Manganese.
Roman numeral 2, and then dichromate dihydrate.
Are you sure it's Roman numeral 2?
I was, and now I'm not.
1, 4.
Would it be 2
Or-
plus or?
Because how many are there?
There is 2 and it has a charge of -2, so that's 7
4.
to 4.
So it has to be 4, right? Because there's
Yeah.
only one manganese, right? And this guy, there's 2 of those guys. And you said, and what is this guy called?
Dichromate.
Dichromate.
I had like your little video part, whatever it shows your face, covering the 2, so I didn't even see that there was 2 of them.
Okay.
Yeah.
Dichromate. And dihydrate, right?
Mm-hmm.
Piece of cake?
Yes. A little.
A little.
Okay. The pie.
Okay. So let's do some acids now. Let's see, where's my acid list? And that's a Q. Okay. Is that right?
No.
No.
No. Okay. Okay, so what should it be?
Is it sulfuros or something like that? No.
Sulfurious.
Yeah.
I'm so furious at you. Okay. And it's OUS because this here.
Yeah, because you have an oxygen there.
That's right. And it's 1 less than the 8, right?
Yeah.
Because it's sulfite.
Yes.
Okay. What about this guy?
Would it be per arsenic acid?
You said per ars.
Per arsenic?
Per arsenic. That's correct. For arsenic acid, because we know that arsenate is AsO4 3 minus. Oops, that should be 3. My bad. 3 minus. Then we know that per arsenate would be AsO5 3 minus. So we know that putting those hydrogens, that the hydronium ion with it in AQ, we make it an acid, and it's ic 8 would be ic, and we put that acid at the end. Okay, and you guys remember that I ate organic apples despite them being poisonous. So 8, ick.
Right.
Height.
And OUS.
OUS. That's right. And then the other one was my ride has hydraulics.
1, 2, 3, 4.
Okay. So if I have what is that guy's name? Yes, that is correct, Michael. Michael asked, is the prefix past per for the adding of more oxygens? Yes. So instead of using hyper, we use per because they were probably high and a little lazy. So they just put PER when they did nomenclature. Okay. When it's less, when it's one less than so fight, it is hypo, like meaning less.
I think he means like, is there any more that supersede hyper or you know, we have.
Is that what you're asking, Michael? So,
yeah.
So in theory, there can be, yes, there are some cases. So I'm trying to think off the top of my head, but they're very rare because stability, they're not stable. I'll have to get back to you on that one. I have to go through my notes from a long time ago.
Is that one hydrophosphoric acid?
You guys are waiting for me to give you a bad answer? Hydrophosphoric acid. That is correct. Okay, so what if I have this?
Is that hydrophosphate?
That'd be trihydrophosphorus dioxide.
Say that again. Try what?
Trihydrogen phosphorus dioxide.
Trihydrogen phosphorus
dioxide.
Okay. That is correct. Yes. So since it's a gas, it's going to be a covalent bond. If it's a gas or if it's a liquid. The only time when it's an acid, it's going to have AQ. Does that make sense?
Yeah.
Yes, it does.
Okay. Let's see.
Dr. Henry, for that one, why wouldn't we use like hypophosphite? Since
Because it is a covalent bond, it is not an ionic compound, right? Or an acid. An acid is a special ionic compound.
okay.
Okay, so that's the reason why you have to pay attention to whether it says AQ or if it says G, right? Because I could give you the same thing, same chemical equation right there, and it'll mean something entirely different, right? So this guy would be, so chemically they behave differently than they would in these circumstances, okay? So this guy is called, can you guys see it? I know it's over there in the corner.
Yeah, we can see it.
Hypophosphorus.
Acid,
Yeah, hypophosphorus acid.
okay? Hypo. Phosphorus. Oops. OUS. Acid. Okay. And so, as I said, that means that it's going to be a gas. If it's a gas, it's going to be covalent. Or if it's a liquid and they have it in there, it's going to be covalent. If it's aqueous, meaning that it's in water, then it's going to be an acid. Does it make sense?
Yes.
Okay. Good question. That's a very good question. Okay. So are you guys feeling comfortable?
More now, yeah.
A little more. Yeah.
A little more now.
Yeah. Now that you broke it down into like the rules and stuff like that.
Okay. Okay, so let's see. Now let's get into that organic chemistry, right? Let's see if I still have anything saved. Nope. Okay, so we have Ute. Pent. Hex. Hept. Oct. Known. Deck. On deck. Dodeck. Okay. 1, 2. So doing those 150 questions, did they help?
You're helping.
For homework?
Yeah. Yeah.
I wish the exam was like it, where we can like just plug in things.
What do you mean?
Like, I don't know, like it'd give you a couple chances to get it right.
Okay. Okay, so we have, first off, let's talk about organic and versus inorganic. Okay. Organic. Okay, what is the general definition of organic?
It has carbons.
It has carbons, right? So something that has carbon in it. Okay, although we have exceptions, we have what we call inorganic carbons. Inorganic basically means it doesn't have carbon, or they're inorganic carbons. So examples of inorganic carbons are carbon dioxide, carbon monoxide, carbonate, carbonic acid. Okay. Okay. So when we talk about organic, we have methane. Now, if it has only hydrogen and carbon, it's called a hydrocarbon.
Can you repeat that, Dr. Henry?
Okay. If it has only hydrogen and carbon in it, it's called a hydrocarbon. Okay, so if I have this guy, and I have this guy, which one of these are hydrocarbons? A or B?
A.
A. A.
Okay. Okay. Which one of these are organic? A or B?
A.
B is not organic?
It is because it has carbon.
Okay. So A and B. So I kind of set you off by now, didn't I? Okay. So both of these would be organic. Okay. You see the difference?
Yeah.
Mm-hmm.
Okay. Good. Okay. Let's see. Hold on one second. Okay, so the first one that we're going to be talking about are hydrocarbons. So one of the simplest hydrocarbons are alkanes. Alkanes are just single bonds. They're all single bonds. So for instance, if I have how many bonds? What is the maximum amount of bonds that carbon can have?
4.
4. So carbon can only have at max 4 bonds. So in this case, you have all of your bonds being occupied by either carbon or hydrogen, right? And they're all single bonds. There are no double bonds here. So that A and E means single bond. Alkanes. Oops. Okay, so the way that we would go about naming this alkane is based upon the number of carbons that we have. So this guy is called an expanded structure. So you basically have everything showing, it's all expanded out. This guy here is called a condensed or compressed structure. And then this guy here is called a skeletal structure. Okay, so expanded, condensed or compressed, skeletal. Okay. So when we're writing carbons that are much, much longer, right? Longer carbon chains, we like to use the skeletal because we're lazy. Okay. You guys with me so far? I know this is a repeat
Yes.
for those who
Yeah.
came to lab. So,
Yes.
okay. So the way that we name alkanes is that we name them by the number of carbons that they have. So this guy has 3 carbons, 1, 2, 3. So we look over here. These are the roots. Meth is for 1, eth is for 2, prop is for 3, bute is for 4, pent is for 5, hex is for 6, hept is for 7, oct is for 8, non is for 9, dec is for 10, undec is 11, dodec is 12.
Are we adding the A's?
You can't add the A's because a lot of times you will use the A's.
Okay.
And those are prefixes, right, Dr. Henry?
Those are prefixes. Okay. So if we have 3, we're going to be using this guy as our prefix, and then we're going to be putting ane at the end of it. Okay, so which one is the prefix for 3?
So would be propane.
Propane.
Okay, so this guy would be propane. Okay, simple?
Mm-hmm.
Okay, so let's see. Let's make it a little bit harder. Okay, so what about this guy?
On deck. And deck.
Okay.
Oh, 11. Okay, so you said undecane?
Oh yeah.
Okay. Yes.
Decane.
Okay. Okay. Piece of cake? Not too bad?
Yeah.
Okay, good. So we said that alkanes all have what type of bonds again?
Single bond.
Single bonds.
So alkenes have at least one double bond. Okay, that represents the double bond. Okay, we name it the same way. The only thing is that we have to say where the double bond is at. Or if there are more than one double bonds, we have to account for those as well too and say where they're located. So you want to count so that it is the lowest number to, let's do this, make it interesting. Lowest number to the double bond. So here, if we count this way, we'll count this way. We'll go 1, 2, 3, 4, 5. But if I go the other way, it's 1, 2, It's 3, 4, 5. Okay, so we want it to the lowest number to the functional group that we're looking for. So in this case, the functional group. So we'd name this guy 2. It has how many carbons?
5.
It has 5 carbons.
Would it be pentene?
Pentane.
Pentene. Okay, so we'd call it 2-pentene. That is correct. Okay, so double bonds are represented by E and E.
And the 2 just states that there's 2, right?
No, the 2 states that where the double bond starts at,
Oh, okay.
because there's only one double bond, right?
So 2 states location of double bond.
That's right. Okay, so if we have this guy, where are we going to start counting at?
At the one.
On the left
At the
side?
double.
From the
On the
left
right.
side.
On the right,
From right to left.
and we don't count the little, at the tip of the, right?
What do you mean? You always count each point. So that's 1, that's 2, that's 3, that's 4, that's 5.
Oh, so when is it when we don't count the little tip? Remember, I think I asked yesterday, and you said that we would just leave it alone.
Is that the
Or I
band?
mean Tuesday.
What do you mean by you don't count the little tip?
That's she's talking about when you do the alcohols. That's alcohols, Diana.
Oh, okay, yeah, you're right.
So remember, it has to
Thank
be
you.
a carbon.
Yes, thank you.
Okay, so because each one represents, if there's nothing there, you assume that it's a carbon. That's a carbon, that's a carbon, that's a carbon, that's a carbon, that's a carbon.
So
Okay.
1, 3.
So it would be 1. You said 1,
3.
3, and it's 5 carbons, so it's pentadiene.
Yeah.
Or you could write it as penta 1,3-diene. So both ways would be correct. Oops.
And the die is for what?
2. That lets me know that there are 2 double bonds. There's one here and there's one there. So then you use the Greek prefixes, di, tri, tetra. Remember those?
Yeah.
Okay. Let's see.
One, two, three.
Okay, so name that guy.
bonds
What?
or double bonds, Dr. Henry?
What was that?
Are those double bonds or single bonds?
Double.
Double bond.
Double bonds.
Because remember, this here means it's double bonds. Single bond is just this.
So 1, 3, 5 heptriene.
Okay, so we'd start counting from left to right.
Yeah, left
Left.
to right.
1, 2, 3, 4, 5, 6, 7.
Yep.
Like you said, 1, 3,
5
5.
heptriene.
Hepta.
Yeah, heptatriene.
Triene. Or you could say hepta 1, 3, 5. Triene.
So to determine like the numbers, like how you put 1, 3, 5, that's gonna be like you're gonna count the number that's not the pointy part, right? You're just gonna count like the ends.
Okay, can you repeat that one more time?
So to determine the numbers, you're putting like, how are you determining the numbers? Like
It's
1,
the
3,
ands.
oh,
The ends, right? Each tip. 1, 2, 3, 4, 5, 6, 7. So each end represents a carbon. So you remember when I drew out the simple one, right?
Yeah.
Right. So that's the same thing as this. 1, 2, 3. Each end represents a carbon. Even though that there are hydrogens there, the hydrogens are understood to be in existence so that you have just enough hydrogens. So you don't keep track of your hydrogens. Does that make sense?
Okay. Okay, so you're determining the locations by the ends of each little carbon.
Yes.
Okay.
Its location is determined by the carbon it's on.
Okay.
Dr. Henry, can you do an example of the other two structures with this one?
What do you mean?
Like doing the compressed structure and then the, I guess you already did the expanded.
Yeah. Okay, so for instance, if we have, because we have the skeletal structure here, right? So this guy would have 5 carbons. That's 1. I need room. I'm going to do it down here. 1, 2, 3, 4, 5. We know there's a double bond between the first and the second carbon. We know there's a double bond between the third and the fourth carbon. And we know, well, that's it. We know that carbon can only have how many hydrogens? I mean, how many bonds?
4.
4. So that's 1, 2 right there. That double bond counts as 2. That means there's a hydrogen here and there's a hydrogen here, right? So we know that there's a bond between the carbon and this carbon. Then that means that there's 1 hydrogen here. So that'll give me 4. 1, 2, 3, 4. There's hydrogen that's coming off of here. 1, 2, 3, 4. There's a hydrogen coming off of there. That's 1, 2, 3, 4. And then this guy would have 3 hydrogens. Okay, so that would be the expanded. Okay, compressed, that would be CH3 because there's 3 hydrogens. This guy only has one hydrogen. So then we put dash CH2. I mean, not CH2, CH. Then this guy only has two hydrogens. So then that would also be just CH. This guy only has two hydrogens. I mean, sorry, it only has one hydrogen. So that's also going to be CH. And at the end, we have two hydrogens, CH2. Okay, and then you can write it in terms of the chemical formula. C5H, that's 3, 4, 5, 6, 8. Okay, now do you see why we like using the line structure, the skeletal structure?
Yeah.
It makes sense now. Thank you.
Okay, questions, concerns? Okay. Let's see. Okay, so we talked about alkenes, 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 and now we're going to talk about alkynes. Got ahead of myself. Let's see. Let me move some stuff over. Are you guys getting it so far?
Yes.
Yes.
Yeah.
Good, good.
Yes.
Something in the chat window. Okay, so as I said, we're going to be doing alkynes. So alkynes are triple bonds. Okay, so these guys are going to look like this. So here, through here, these guys are going to be totally linear. So when we draw the stick structure, we also want to draw it as being linear. So we draw a triple bond. And then we draw, in this case, there's one more carbon coming off of it. Okay, so if we do our numbering, we have 1, 2, 3. So what would this hydrocarbon be named? Based upon the trends that you saw with everything else. Can you guys hear me?
Yes.
Yes.
Yeah, I just don't know the answer.
How many carbons are there?
3.
3.
3.
There are 3 carbons.
3.
Okay, so it should start off with what? What should be the prefix?
Prop.
Prop?
Prop.
Okay.
Yeah.
So we should have a prop. Okay. Now, when it was a double bond, we put an E in it. When there's a single bond, we put an A and E. So what do you think we're going to be putting here?
Y and E.
Y-N-E-S.
Y and E. Okay. Okay. So now we just have to say where the bond starts at. Where does it start at here?
1.
On the third carbon.
Does it start on the third carbon?
No,
Would it be the second one?
B1.
the
One.
first one.
Okay. Because remember, you're always going to number it so that
The lowest.
the functional group, which is the triple bond, has priority. So it always will start off at 1. The one that's the most important will be the first carbon. Okay. Does that make sense?
Yeah.
Yes.
Okay. So that was an easy one. Let's make a hard one. Okay. This guy. First thing we want to do is what?
Count the
And the carbon chain.
on the
Okay. Are we going to count from left to right or right to left?
from right to left.
Right to left.
And why?
Because that's
So
the
the bond is located in the lowest.
That's right. Okay. So
You always start with the 1.
three.
3. Okay.
No 9.
3, no 9. Okay.
Okay.
So let's make it a little more challenging. That was too easy, right?
I have a question really quick, Dr. Henry.
Okay.
So for the one that we just did, you know, where you have 1, 2, and then you have 3, 4, and it's on the line. Why is it 3, 4 like on one line?
Because it has to be, it's a linear structure, meaning it's straight across. If we look at this guy would be a linear structure. See this guy up here? Right? So it would go straight across. So it doesn't kink like the other one.
Oh.
Which also which often makes it harder for us to see it, right?
Uh-huh.
Yeah.
Okay, thank you.
Okay. Okay, so this guy. Oh, wait, I wasn't done. Hold on. Okay, I'm done now.
You start from right to left.
Start from right to left. Okay. So that's 1, 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8.
So it's 3.
3, 7 octane.
3, 7.
The 3, 7.
2, 6.
Yes.
3, 6.
3, 6.
Oh, 3, 6. Sorry.
3, 6. Octa.
Wait,
time.
Octa,
Di.
Di,
Dia.
Okay.
Why wouldn't it be 2-6?
Oh, you're right. It's 2-6. Because it starts at the 2, right?
Okay.
Good eye.
So for these, there's straight lines instead of the little triangles, or not triangles.
Yeah, I know what you're saying. The little kinks, right?
Mm-hmm.
Yeah. So they're straight lines because it's triple bonds right after the kink. Sorry. You have the triple bond is linear, right? So that means that the next molecule has to be linear with it because the triple bond doesn't allow for the kink. Double bond can, but not the triple bond.
Oh, okay.
Does that make sense?
Yeah, makes sense. Thank you.
Okay. How are you guys doing so far?
Do you think we can do another problem with the triple bonds?
Sure.
Yeah.
It'll just cost you $75 million. That's all.
Charge it to heart now.
Let's see.
Dr. Henry?
Yep.
For this one that we just did, could we have started on either end?
Yes, because it was even is the same number either way.
Okay. Did you already explain the bend?
Yes.
What was it?
Because triple bonds don't allow you to be anything except. Okay. Let's add one more. So 1, 2, 8. Okay.
So you start counting from left to right?
Okay, so we have, so if we start from left to right, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8, that's 9. Okay, so if we started the other way, that would be 1, 2, yeah, so that would be the shortest distance for all of them. So, okay.
Would it be 1, 3, 9?
1,
or 3, 8?
3, 8. Yep.
1, 3, 8. And then not, would it be like non-tri?
Nona. Tri. Okay. Or the other way of doing it is Nona. 1, 3, 8. Let's try 9. Okay. Okay, questions, concerns, Cash?
No.
Trying to see. There's a few questions I missed there. Mike, did you answer your own question? Michael? Yep, okay, good. Okay, let's see. Okay, so we know that we have a double bond, a triple bond, and a single bond. And those are all hydrocarbons, right? So in organic chemistry, nomenclature is based upon priority. So if you have both of those structures, let's say a double bond and a triple bond, it's based upon priority. So I'm going to give you the priority of each of these, and then I'll talk to you about that. Let's see. Could you guys not see my whiteboard before? My computer's been acting a little bit crazy today.
No, we could. No, we could see him.
Okay. So in terms of priority, we have alkanes is at the very bottom right now. There's going to be one that goes below it. We have alkyne in second, and alkene is top priority. Okay, so what does that mean?
Does that mean we'll write it first?
No, that means that, so like when men and women get married, the woman takes the man's last name, right?
Oh yeah, it takes the suffix of it, right?
That's right. So it's kind of like that. So it has priority. It's the most important. So we get Ian's last name because he's more important than the ion. Okay.
So priority means
Oh, yeah, you, Mommy.
Me too.
You love me too?
Oh, no. Sorry.
Okay. I was just feeling left out there, you know. Okay, so I'll explain to you these things here in a second. Okay, so in terms of priority, these are the priority. This is the priority list. Okay, so let's say we have okay. And that's a double bond at the end there. Okay, so what will we name this guy?
It would be alkene.
Okay, so how would I start? Let's go with the full name. So where would I start counting from? Left to right?
From right to left.
So that's 1.
This is the shortest.
2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, so when we have both of these here, we have to use what we call a prefix for the triple bond, or we can use it within the structure itself. Okay, so we would say there's a triple bond. So at the third position, so we'd say 3 dash YN. And then we know that the double bond is located where?
At 1.
At 1. So 1, and it's.
That would be YL.
What is, there's how many?
9.
9. So.
It would be
Known.
Nona? Oh, no.
Nonine.
Nonine. Yes. So 1 nonine. Okay. So this tells me that I have a triple bond between the third and the fourth carbon, and it's 1 nonine. So that's one way of writing it. The other way of writing it is 1 nonine 3 dash YN dash ENE. Okay. Or the third way of writing it would be nonine dash 3 dash YN dash 1 dash ENE. All 3 are correct. All 3 are used. So you'll run across it when they're done that way. Okay, so we're gonna try one more.
Yes.
Yes, please.
Okay, so that's 1.
I'll hold the hat.
Okay. Okay.
So 1, 2, 3, 4, 5, 6, 7, 8. And
No, the I'll hold the hat.
okay, here we go.
So you start counting from right to left.
Okay. That's 1, 2, 3, 4, 5, 6, 7, 8,
9.
9. Okay.
And then it's 1.
Okay, you said 1.
Yeah. And then 4 or 5? 4.
4. That's right.
Then 6 and 8.
Okay. So, but we have double bonds and triple bonds, right? So it should be 1, 4, and you said 6.
Yeah.
Okay. And then
8.
8. So how do I account for the double bond? I mean, the double bond being different than the triple bond.
I don't know, it's 9.
So I would want to write that first. I'd
Yeah.
write 8
8
dash YN And then I would write, is it known? Nona, try. So that would be one way of writing it. Or it could be Nona.
One.
Sorry, hold on. Nona 8. Ein 1, 4, 6.
Trying.
Trying. Yep. These guys should actually have Nona in it as well too.
So the dash YN represents the triple bond?
The YN represents the triple bond, yes. Yep. So like the YNE represented the triple bond. But in this case, since it's not the suffix, it has less priority, we just use the YN. Does that make sense?
Oh,
Yeah.
so you're putting the one that's the least priority in the front, and then the end is the suffix because that's the most prioritized.
That's right. Just like we do in real life, right? So
Yeah.
the man is the most important. So we get the man's last name, right?
Sure.
Okay, don't throw anything yet. Yeah, I'm just joking. Okay. How are you feeling?
So, Dr. Harry, so which one was the one that has the highest priority? Is it alkane or alkene?
It is alkene has higher priority than the alkyne. Alkane is the lowest priority, right?
Okay.
So they're listed in terms of priority down here. You see it? Alkane, lowest, alkyne, alkene. So the double bond, and it seems weird, I know, but the double bond has more priority than the triple bond, because the triple bonds, they exist, but they're less frequent. Okay. Okay. Good. Okay, so let me add some more, and then we're gonna have to go to my office hours to kind of finish up on this. Okay, because I have people waiting for me. Let's see. So the next thing that I want to talk about are side chains. Let me pull up. Let me go back. I've been missing things here. Hold on. Is this helpful?
Yes.
Yes.
Yes, it is.
Yeah, get to that.
Funny, time flies by so fast.
Mhm.
Okay, so for the side chains or branching hydrocarbons, 1, 2, 3, 4, 5. We'll start off simple, and then when we get back to the room, we'll get more complex. Okay, so in this case, you want to find the longest carbon chain possible, right? I should show you what I mean. Let's go.
I love you, Mommy.
Love you too, hon.
Okay, so in this case, you want to find the longest chain possible. So if we count the carbons here, we have 1, 2, 3, 4, 5, 6, 7.
3, 6, 5, 4, and 3.
So we have, if we count this way, we have 1, 2, 3, 4, 5, 6, 7, 8. Right? So the purple would be the longest chain. So we're going to try to use the purple. Now the question is which way we're going to go with the purple. So you want to try to set it up so you have the shortest distance to a functional group, right? So if I count it this way, 1, 2, 3, 4, 5, 6, 7, 8, going in this direction. So I have a functional group on the second position, and I'll have one on the, what's that? Let me count it, rewrite it. 1, 2, 3, 4, 5, 6. Oops. Did I miss one? So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'll have on the pink chains, I'll have a functional group on the second carbon and a functional group on the fourth carbon. If I go with the purple, I'd have a functional group on the fourth carbon and also on the second carbon. Now, you want to base it upon priority, right? Try to get the lowest priority, so you take care of that guy first, right? So the bigger chain typically has the most priority. So in this case, we have 1, 2 carbons on this side, and we only have 1 carbon attached on that side. Okay, so 4, what is it? 4 and 4, it looks like 4 and 4. So this guy going with the second and the 4 would be the best choice. So we're going to go with the pink. Okay, so if I go with the pink, my longest chain is how many carbons?
Would it be
8?
8. So we'll start off with the very end. So that would be, and it's all single bonds. So then what would be the very end of it? It would be called what?
Octane.
Octane, right? Okay, so on the second carbon, and I'm going to circle it, possibly. On the second carbon, we have a single carbon. So coming off of this second carbon right here, there is a single carbon coming off of that. So 1 carbon, what prefix do we use for 1 carbon?
Methyl.
Okay, that's right. So we're going to be using methyl. So we're going to add a YL at the end of it, meaning that it's a side chain. So it's methyl. Okay, and it was off of the second carbon. So we say the location. Delete this. So it's 2-methyl. Okay, and then off the, let's see, it would be the fourth carbon. We have this guy right here. Let me circle it. And that's 1, 2 carbons. So 2 carbons would be what?
Ethyl.
Ethyl. So, and that's coming off of the fourth carbon. So it'll be 4-ethyl. Octane. Does that make sense?
Yes.
Then I have a question. So on these, because we're writing the 4-ethyl first because it's 2, right? It's going to apply the same rule of like a double bond?
Well, so technically it would be, okay. So the easiest thing to do is alphabetical, right? That is the easy thing to remember, alphabetical. But usually if you're working with just the hydrocarbon, it usually goes by in the order, meth, eth, prop, depending on the length of the chain, right? That's usually how it's done. However, if it's just hydrocarbons, but when you start adding other functional groups, you start going with multiple choice. But you'll see that most people will just go with multiple choice because in that way you don't have to keep track of that alphabetical. So you don't have to keep track of what you're working with. You just kind of work on autopilot. Does that make sense?
Yeah.
Okay. Questions, concerns, Cash?
Dr. Henry, can you explain how you got 4-ethyl again?
Sure. Okay, so the first thing is that we want to find the lowest number for our functional groups on the side chains, right? So if we went with the pink numbers, so that's 1, 2, 3, 4. So that would be the fourth carbon right there. So on the fourth carbon, we have this guy attached to it that's circled in brown. Okay, so in that it has 1, 2 carbons attached. So 2 carbon is eth, and then since it's a side chain, we put YL at the end of it. So it'll be 4-ethyl. Okay, on the second carbon, 1, 2, we have a single carbon that's attached to that. We put 2-methyl.
Yes.
Okay, so let me make sure. Let me pull up some stuff, make sure I still have any. I may have to type it all again. Okay, we have that. And the other one I have to type. Let's see. Thanks. Sorry, I didn't type this out again. Okay, so I'm going to draw another one up and see if you guys can name it. Let's see, make it simple first, and then we'll make it a little more complex afterwards. Okay. Hey, you guys see that? Are you with me?
Yep, see it.
Yes.
I just get worried when it's so quiet.
Would we start from the left?
So you want to start from the left?
I would start from the right.
So in terms of priority, these guys are all kind of the same level, right? Even though that the one is longer, right? So you want to try to get to the lowest functional groups, right? For these guys. Yeah. If they're a double bond in one of the side chains, that would be different. So then you would change your priority based upon that. So we started from the other way. Come on. Okay. So if there's a tie, let's say I have a choice between my ethyl and my methyl, and there's a tie between the two. Let's say they're the same distance away, but one is on one end and one is on the other end. Then I choose my ethyl in that case. Okay, so is that the longest chain?
Yes.
Yeah.
Okay.
Yes.
So what is my last name?
Octane.
Octane, okay. And then what's going to be in front of it?
2, 2, 3 trimethyl.
Okay. Okay.
And then 5 ethyl.
Okay. Piece cake?
Yes.
Yes.
Okay. So you want something a little bit harder?
Yeah.
That looks like waves.
Dr. Henry, sorry to interrupt. Do we have an exam coming up?
Yes, ma'am.
Next week on Friday, correct?
It opens on Friday. So your practice exam is going to open up on Monday. And so you'll have Monday until the end of the exam to do your practice. Your exam will close on Monday night.
Monday night. Okay.
Yeah.
Got it. Okay, thank you.
So the exam opens on the 23rd, right?
Yes.
Okay. And then it closes on Monday.
Yep.
The following Monday. Okay.
Okay. And now it's a double bond here.
So on these one, does it matter which side we start from?
What do you think?
And well, these ones are the longest bond. I mean, the longest chain, right?
So we still want to go with the longest chain, and we also want to try to encompass in the longest chain, if we can, the one that has the highest priority. Who has the highest priority? The double bond, the triple bond, or the little side chains?
The double bond.
Double bond. So we want to try to encompass the double bond if we can.
So it'd be from the left.
Okay, so you say from the left?
Yeah, because the double bond starts on the left side.
That's right. 2, 3, 4, 5, 6, 7, 8, and 9. Okay.
So it starts at 3, right?
The double bond starts at 3, yes.
So it would be 3. 3. It would be. So 3. Would it be 3 E and E?
Okay, 3 E and E.
Or 3.
3 non-E.
Oh yeah, because
Jesus.
Okay.
3.
What was that?
Where that's because where's like the triple bond is located on number 6.
Okay, so you're saying 6. And what would be my prefix that I would use for a triple bond?
YN.
Okay.
Methine.
YN. Okay. And then what else? Do we have anything else? Any other structures? What's coming off that 4th carbon?
The 4th.
We have a carbon.
Okay, we have a carbon, a methyl group. Okay. Do I have another methyl group anywhere else?
2. We have 2 methyl groups.
I have 2 methyl groups. So I have one on the 8th carbon and one on the 4th carbon.
Would it be 4, 7?
4, 8.
8 dimethyl.
4, 8.
Dimethyl.
4, 8 dimethyl.
And 5 propyl.
And 5 propyl.
So do we have to put dashes, like say between the dimethyl and then the 5 and then the propyl?
Yes.
And the 5?
Yes, you want to put their dashes in. Because it helps us. So the dash lets us know who it pertains to, because you can get your branch structures could have branches coming off those branches. And so then you're going to also include parentheses and other dashes to tell me that. So.
What about, I think she means in between the dimethyl and the 5.
Yes.
Oh.
Because in the lab 7, the first one that we have to draw the skeletal structure, it has the dashes between all of them.
Okay. So you don't have to put it between the dimethyl.
Okay. Why does the lab one have it on the 51st question?
Yeah, it can, but it doesn't need to.
Oh, you don't have to?
Yeah.
Okay.
Yeah. Thank you for translating for me, Heather.
No problem.
Dimethyl, propyl. Yep, that is also correct, Edgar. So Edgar did it the other way. Copy, I'll put it in here.
I have homework questions for later tonight, if you have time.
Okay. Okay, so how are you guys doing so far? Pretty good?
Yeah.
Doing fine, yeah. I just had a couple questions about the lab mainly.
Okay.
Me too.
Okay. Okay, so let's see. The next one, go back, let's see this. Our next group is, and I'll have to make a correction to my other class. Let's see, this guy.
Is there one more to learn? A new one?
There's more. There's more.
Is that what you're teaching right now? Another one?
Yeah, that's what I'm getting ready to say right now. Hold on. Okay, so the next one is halo. They're actually called halo alkanes. And I had misspoke and I said alkaline halides, right? Alkaline halides are a little bit different. So.
Okay. So everything's the same, but the name?
Yeah.
Okay.
Okay. So in this case, we're working with halogens. Do you guys know who the halogens are?
Could you lift it up a little? I can't see because of black bar.
You guys see it? If I put it up here, that's fine?
Yeah. Yeah.
You said what group? What group are the halogens in?
17.
17, that's right. Okay, so the halogens, the way that we would write this is we'd count the number of carbons on the main chain. How many carbons are on the main chain?
5.
5.
So that's 1, 2, 3, 4, 5. So we'll say where the halogen is coming off of, and we'll use the prefix for that halogen, which is fluoro. And then we just put an O in at the end and get rid of the INE. We say where it's located. It's located on the first carbon. So we'll call it 1-fluoro. And a 5-carbon chain is called what?
Pentane.
Pentane. Okay. And you'll see it, not pentane. Oops, sorry. Okay. Sorry about that. Pentane. Sometimes you'll see, again. Sometimes you'll see it where we put together 1-fluoropentane or separate. You'll see it both ways. Okay, simple?
Yes.
Okay, so let's see. 1, 2, 3, 4, 5. So we'll go. Okay. So what will we name this guy?
It's going to be hexane at the end.
Okay. So we counted the carbon, so that means your longest chain is
6.
6. So which way am I counting, left or right?
Left.
Counting from the right, meaning left, yeah.
Okay, so I'm counting this way or this way?
To the left.
Okay.
To the left, that means right to left.
Yes.
Okay, because the alkanes have priority over the halocanes.
I'm making 8.
Okay.
Two, 3, 3 trimethyl.
2, 3, 3 trimethyl.
But before that, you put 4 chloro because it's alphabetical.
4 chloro. Okay.
And then you put after chloro, you put 5, and I don't know how to translate iodine to O.
It's
Ido.
Iodo.
Iodo.
Sounds like a dinosaur.
Okay. 5 iodo 2,3,3 trimethyl hexane. Okay. Good, bad, ugly.
Good.
Jane, what do you think?
I'm still trying to process it, but I'm writing all my notes.
Okay. Destiny.
Yeah, I think I understand it. What makes more sense is how you said you have to alphabetize it. So
Yeah.
you start like from the first halogen, then the next one.
Yeah.
Okay. Yeah.
Yeah, that's right. Okay. Let's see. Let's give you guys one more and then we'll move on to the next structure. Let's do.
So we start from the left because the double bond is the priority, right?
Okay. Yep.
So let's see.
That the
Does it
longest chain?
matter? Does it matter if you go that way? I wanted to go the other way.
You go the other way.
Okay.
It's the same either way, right? In this case.
Right. Okay.
Yeah.
Would it be 2 chloro?
Okay. Chloro.
Six hexane. Or shit, sorry. Hexane.
Hexene.
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 After 2 chloro, you would put 4 ethyl because of alphabetical order.
Mm-hmm.
4 ethyl. Anything else?
Followed by a 3 methyl.
And am I forgetting anything?
1 hexene.
Okay. Are you guys good?
Yes.
Yeah.
Yes.
Okay. It just gets so quiet after a while.
The hot. A hot here.
Yeah, I agree. Oops. Oh, crap. Sorry. Okay, so our next guy that we're going to be talking about is amines. So the prefix for that is either amino, which is hardly ever used, and the suffix is amine. Okay.
So those take precedence over the alkenes?
Yes. So amines take precedence over alkenes. So amines basically have nitrogen as like the center. And nitrogen can have three bonds. So typically you have your lone pair, and then you could have one hydrocarbon, you could have another hydrocarbon, or you could just have hydrogen there. Right? Okay. And so when we use R means a functional group, or it can just stand for hydrocarbons in general. Okay. So let me give you an example. Okay. So in this case, this nitrogen has it has a methyl group on each side, on all 3 points where it can hold something. So this guy would be called trimethylamine. What do you think this guy would be called? Let's see. Evelyn, are you there?
Yes.
So how many carbons do I have on this chain right here? Let's count it. So
2?
Yeah, 2. That's right. 1,
2.
That's right. Okay. And let's see, Jane, how many carbons do I have on this chain right here?
5.
1, 2, 3, 4, 5. Okay. So the hydrogen we don't take into consideration. It's just part of the amine structure. So then we would call this guy And you do it alphabetically.
It would be ethyl pentylamine.
So it'd be ethyl pentylamine. Okay, let's do one more. Okay, what about this guy?
There's 2 ethyls and 1 propyl, looks like.
Okay.
So it would be diethyl propylene or propylamine.
Diethyl propylamine. Okay. Simple. Veronica?
Still processing it.
Daisy?
I'm trying to digest that. I will get it.
Okay.
Same here.
So just remember, it ends with amine, right? So you just look at each of the guys that are on there. I'll give you one more. This will be a good one, and it'll be clear.
How do you know that's amine?
Because it has an N. The nitrogen makes it an amine.
Okay.
Okay. Okay, what about this guy? Okay, we're gonna have Veronica. Are you with me?
Yeah.
Okay, so how many carbons are coming off of, I'm gonna call this the A side. This is gonna be the B side. This is gonna be the C side. So tell me how many carbons are coming off onto the A side.
1.
1, that's right. Okay, so we're gonna put a 1 by it. Okay, so since it's 1 carbon, it's gonna be what? Meth. Okay, so, and since it's a side chain, you put the YL at the end of it. So we'll call it, say, methyl. Okay, now on the B side,
diethyl?
no, it's how many carbons?
Oh, we have 2.
We have 2, right? So if it's 2 carbons, we use
F.
F.
Oh, not diethyl.
Okay, so then we're going to have ethyl.
Can't see myself. Hello.
See it now?
Mm-hmm.
Okay, this guy was methyl. Okay, now what about this guy right here? How many carbons does that guy have?
Is that 3?
Let's count.
4?
4, that's right. 1, 2, 3, 4. So a 4 carbon chain would be called side chain.
Butyl or like
butyl? Butyl.
Yeah.
That's all right. It takes a little bit getting used to that. Okay, so we have ethyl, we have butyl, and we have methyl. So if it's done alphabetically, what would it be?
Butyl, ethyl, methyl.
Okay, so we have butyl, ethyl, methyl, and then we just put the word amine at the end of it. Because
It has an N.
that's right. Because that guy has the priority.
Okay.
Simple?
Yeah. Thank you.
Yes.
It's kind of like a crossword puzzle where you do each side and then you complete
You
the
put it all
word.
together.
Yeah.
Yep. Okay. One more, or are you guys good on that?
Can you do one more, Dr. Henry?
Yeah. Oh, we'll make it a little bit harder. So alphabetical actually is going to be with all of nomenclature. So when you start having more and more functional groups, you have to do it alphabetically. And then, of course, the one that has the most priority has the last name. Although there are exceptions, and I'll talk about that in a second.
Would this one be 2-chloro?
Okay, so now this is kind of a special case, right? So what it is that you have your main chain. So how many carbons are here?
3.
3?
Yeah.
Okay, so then there's 3 carbons. So then you would have this guy would be called 3 carbons would be what? What would a 3 carbon chain be called?
Propyl.
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 Okay. So propyl. Oops. And you said on that propyl there was what?
Chloro.
So we have a chloro. And where's that chloro located at? 1, 2, 3. You always start from the carbon that is closest to the functional group or the priority group. You said it was on the 2. That's right. So it's 2-chloropropyl. And so that's what that side chain will be called.
So the functional group does not change.
That's right. The functional group does not change. Yeah.
Okay.
Yeah, it's always, in this case, it's always going to be that amine, right? So then we have what? Ethyl. And then we have
methylamine.
Yeah.
Oh, okay.
Okay. Okay, let's see. We have one more, and then we'll pick up the rest when we get back next week. Is that right, Edgar? Did I give you guys one more, or did I give you guys 2 more?
I just came back.
Wasn't it alcohol that I stopped at today?
You did stop at alcohols, yes.
Okay, I just want to be sure. Okay. Okay. So everybody's favorite functional group, alcohols, is next on the list. So alcohol has priority over all of these guys, although even though that alcohol has priority, amines, most organic chemistry will name it with the amine rather than with the alcohol. And so a lot of the chemicals that you see, like your shampoo and stuff like that, it'll have like methanolamine, you know. And I'll show you what that's going to look like after I introduce alcohols. So hydroxy is the prefix, and then the suffix is OL. Okay. Okay, so for alcohols, if you have an OH attached to your hydrocarbon, it's considered to be an alcohol. Okay, so let's see. Okay, what would this guy be called?
Ethanol.
Okay, so this is drinking alcohol. Okay, if the alcohol is terminal, you don't have to put a number. So in this case, the alcohol is terminal, we don't have to put a number, right? Plus, we know that it's always going to start off at the functional group. Okay, so here, the alcohol isn't terminal, it's in the middle, right? So it's called a secondary alcohol. So then this guy would be called, terminal means at the end.
Isopropanol.
This guy would be called, the common name would be isopropanol. The proper name would be you count the number of carbons. How many carbons do we have?
3.
1, 2, 3. So we would call this guy, you want to take a guess?
Would it just be propanol?
No, it would just be propanol.
So it would be...
Yeah, you're right. When you said 2, right? So 2
dash propanol?
That's right.
Okay. Because it starts at that point, right?
That's well, it's where that the OH is located at. It's on the second carbon. Okay. So
ISO, like how do
ISO means the same. So you have it's equal parts, right? So you have one carbon on this side, and you have one carbon on that side, and you're splitting the OH down in the middle. So it's on the second one. Okay. So you can use that term isopropanol. So isopropanol is rubbing alcohol. Okay. So this guy, what is this guy called?
Would it be 4-butanol?
count the number of carbons. Let's do that first.
3.
Be the propanol.
So that's 1. Oops. Sorry, let me fix that. Oh, 1, 2, 3. You said, what was it?
Propanol.
Propanol. Yeah. So this guy would just be called propanol. Or you could call it 1-propanol, which is the same thing as propanol. Okay. Let's see. I'm going to make it a little bit harder. Let's do some chains. And we'll do actually, let's do this. There you go.
It would end in hexanol.
Okay. Are you sure?
Yes.
You said 1. Where would I start counting, I should say?
Count left, so start at the right.
Okay. So 1, 2, 3, 4, 5, 6. So you're saying it's hex?
Yeah. Hexanol.
Are you sure?
Yes. Wait a second.
Would we have 2 of them?
We have 2 of them, yes.
So it'd be like at 2 and at 3, right?
Okay, so you would say 2, 3.
Hexanol?
Dash.
Hexadiene. Oh, because there's 2 of them.
Hexadiol. Okay. And then what will go in front?
4,5-dimethyl.
Okay. And this guy would be called so I'll give you a hint. So it's going to end with amine instead of ending with an alcohol. So even though that amines are less priority, often organic chemists will make exceptions because it's a lot easier to write it one way than the other.
Now, with this one, there's 2 methyls, but only one has OH attached.
That's right.
Would it be dimethanol or methyl methanol?
It would be methyl methanol.
Okay.
Yep. So, or it would be methyl. Yeah. So it would be ethyl. Actually, be ethyl methyl methylamine.
Okay.
Okay. Questions? Concerns? Cash?
No, but are we gonna review that next time we have lecture?
Yeah, we will probably review it, but we'll probably start at the amines and work our way back up.
Oh, okay.
Okay. So do one more for the road. What was that?
By any chance, is this recorded and like, will you be posting this?
I will have them post it. Yeah,
Okay.
it should be recorded. Knock on wood. I've had a lot of issues this week, so
Okay.
I'll see if it is. If it isn't, then I don't know.
Okay.
We'll talk about it. We talked about it
Yeah.
earlier today. Hopefully, it's recorded then. So.
Okay. Thank you.
Dr. Henry, I had a question about the lab.
Yep.
So I put like the formulas in Excel, but I can't write them as like, you know, the formula with the subscript. It's just literally like.
Do you want me to show you how to do that?
Yeah. Sure.
Yeah. Okay. Okay. Let's do this one real quick, and then I'll show you real quick. So if you guys go ahead and name this one.
So it's going to end in pentanol because there's 5 carbons.
Okay.
Ending in 2 pentanol.
Like this? Pentanol?
Yes.
Are you sure?
I am sure this time, yes.
Do you want to put money on it?
Yeah, I'll put $5.
Okay. You heard him. Everybody heard him? What about that double bond?
All right, I'm already losing $5.
I'll collect for Dr. Henry. You could send it to me.
Yeah, but they'll be $5 for all of us present witnesses.
You can split it.
See how that multiplied? You thought you were just betting $5, huh? So you can do it this way, or you could have done it 2 penta. Yeah. Okay. Good, bad, or ugly?
Right. Dr. Henry, so you guys were mentioning Excel. Is that for the last lab or the
for
one?
Nomenclature, I believe, right?
I mean, I just used Word or Google Sheets. It's all the same.
There's 2 labs out right now, right?
Yeah, there's lab 7, which is also nomenclature with balancing equations.
Right.
Yeah.
So which one are you guys talking about that requires a spreadsheet?
She said she did it in the spreadsheet. It doesn't require a spreadsheet, but she chose to do it in the spreadsheet. I was just going to show how to do it.
I can handwrite it?
You can handwrite it, yes.
That's what I was about to ask.
Yes. Okay,
So is
let me.
Lab 7? Oh, sorry.
No, go ahead.
Is Lab 7 still going to be due tomorrow?
No, Lab 7 won't be due tomorrow. Lab 7 is actually due next. Oh, Lab 7, the nomenclature lab?
Yeah.
Yeah, you should be able to finish it even without me going over everything. We can talk about it right now because there's only, 5 questions left?
The last 10 are skeletal structure, and I had questions on 3 of them.
Okay. So let me show her how to do the Excel sheet. I can't even think straight. Subscripts on Excel. Okay.
Okay.
Let me find my spreadsheet. Come on.
Also for the lab, the last one that you guys did on Thursday, are we gonna have to record ourselves if I missed that class?
No, you won't have to record yourself doing it. It's a dry lab. The only time that you have to record yourself is when it's a wet lab,
Okay.
Meaning that you have chemicals and stuff going around, or
Okay.
you're cutting out stuff, and where there's a physical event going on.
Okay.
Okay, let's see. Okay. Okay. So what you're going to do is highlight the letter. You're going to click on this. You're going to hit superscript. Can you see the superscript thing come up?
Yep, I see it.
Yes.
Oops, this should have been subscript, sorry. Got carried away. Subscript, and then there you go.
Voila.
I use Google Sheets and I already put like all of them in. Is there a way I could make it quicker? Or
Yes.
oh yeah.
For Google Sheets, you hold down Control and then you press the button for comma.
You said button for comma?
Yeah, so Control, comma.
Not the number 4.
Thank you.
Okay, questions, concerns? So yours was in Google Sheets? I thought you said it was in Excel.
Oh, sorry, my Google.
Okay, that's all right.
Use Excel.
Okay, well, but now you know, so.
Yeah.
Now I know. I'll probably forget it by tomorrow, but. Okay, so we were talking about the lab. Let's see. Does anybody have it available right now so I don't have to go searching?
I have it pulled up if you'd like me to share my
perfect.
screen.
Do you mind sharing your screen?
No problem.
Let me stop sharing mine.
Okay, here we go. All right. Are you able to see it, Dr. Henry?
Yep.
Yeah.
Okay, so the problems I had were with problem numbers 54, 55, as well as 60.
Okay.
And, well, 60 is the easiest one. Is this misspelled? Is it supposed to be hexanine?
Nope. Nope. So these are new functional groups that we have.
You're drowning. You're in.
I'm sorry. These are functional groups that we haven't gone over yet, but I'll show you what they are real quick.
Okay.
Let me see. Can I annotate?
Dr. Henry, if you didn't go over them and people miss lab, like this outside class time, your after hours, are they going to be responsible for?
Yep. Because yeah.
They're 53 as well.
Oh, you're talking about in terms of being due today. So maybe I'll extend it for next week. Well, but I'm going to show you just in case.
Okay.
So I changed my mind.
Somebody brought up 53 as well.
53 as well? Okay, we'll do that one as well too. Okay, so 54 is a carboxylic acid. Carboxylic acids look like this. So R again represents the functional group, right? So when you count carboxylic acid, you have this carbon here. This represents that double bond there. So it's really a C that's there. So you count that C in terms of the number of carbons that you have. So this guy has how many carbons?
6.
It has 6 carbons. So you'd have a C there. So that's 1. There's 2. There's 3. There's 4. There's 5. There's 6. 1, 2, 3, 4, 5, 6. And then you have OH. Okay. So then that guy would be the structure for hexanoic acid.
Okay, so it's just the final carbon in the chain is double bonded with an oxygen and single bonded with a hydroxide?
That's right.
Okay.
And that's a carboxylic acid. That's the family.
Okay, makes sense.
I can spell it carboxylic.
Can you explain that one more time? I did not get that at all.
I
Okay.
just want to know what the top is with the bottom
Same.
drawing. Is that
Okay.
one better?
So for carboxylic acids, you have a carbon double bonded to an oxygen. That's the same thing that's showing up here. And then that's also bonded to just an OH, an hydroxyl group, right? So this here is the functional group for carboxylic acid. Okay. Now, when you name it, you count this carbon in the name. So that's one. That would be your first carbon. Then this would be your second carbon. This is your third carbon. This is your fourth carbon. This is your fifth carbon. This is your sixth carbon.
There must be a delay. I think there's a delay. I think there's a delay in your voice from your actions, like you writing on there.
Oh, yeah.
That isn't me writing on there.
That was me to make it easier.
Oh, okay. I was like, there's a lag. Okay.
But the thing is that this is the functional group. It has priority. So this is your first carbon, not your sixth carbon. Does that make sense? So you'd write it the other way around. Yeah. So that would be 1, 2, 3. And your handwriting was so much better than mine. I should let you write 6. Okay. Does that make sense?
Yes, now that makes sense.
Okay. So, and again, that's for carboxylic acid. Okay. So 55. So these guys, these are called ethers. Now, an ether has an oxygen and it has a functional group on one side and it has another functional group on the other side. So these guys are called ethers. Okay, so if we wrote this guy, in this case, it says butyl propyl. So what do you guys think that's going to look like?
Oxygen in the middle with a butyl to the left or
1, 2, 3, 4. So that's 1, 2, 3, 4. Okay.
And a propyl to the right.
Okay, so then that's 1, 2, 3.
That's it?
That's it.
Okay.
Yeah, ethers are one of the simpler ones.
So it's propyl because there's 3, right?
Propyl, yeah, that's right. So that's, yeah. So that's 1, 2, 3. And butyl, 1, 2, 3, 4. Okay.
Dr. Henry,
Yep.
in the carboxylic acid, you counted the carbon. Oh, never mind. Now I know. So, because you counted the carbon as like as
my first carbon.
Yeah, now I get it. I was comparing it to the other ones that we did. Okay, that makes sense.
Okay. So the next one is, what was the other one that you had?
Number 60, and someone else wanted 53.
Okay. So 53. So 53 are for aldehydes. Now, aldehydes are very, very similar to carboxylic acid. The only thing that's different between an aldehyde is you have the double bond, the carbon there, and then you have just a hydrogen instead of an OH on that side, and then you have the functional group over here. Okay, so if it is octanane, that Al, so Al would be the subgroup, so that means there's 8. So this would be your very first carbon, and then for your R, you'd continue with the rest of your carbons.
Okay.
So it'll be, get my eraser. Now I'm just drawing that C there so you guys can see that double bond. Normally we just draw it like that for ease. So that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 3, 4, 5, 6, 7, 8. Okay. And so that's what that guy would look like. And then the last one. So ketones are similar, again, to these guys as well. They have a double bond, a carbon, and then one functional group and the other functional group. Okay, so the double bond is located at the second position. So we would be, so this would be our second carbon, right? So then you'd have one carbon there. That would be your second carbon. And then 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So that would be your hexanone, and then your 2 hexanone. And then this guy has a methyl on the fourth carbon. So if this is 1, let me use different colors. Can you guys hear me?
Yes.
Yeah.
1, 2, 3, 4, 5, 6. So we'd have a methyl group on that fourth carbon. Okay. So you see the distinction between, so these are ketones.
That's number 60, right?
Yep.
Okay.
So those are ketones. These are aldehydes. And they end with Al. And then these are carboxylic acids. So these three are very similar to each other. Was that good?
Yeah.
So I'll actually extend it because we didn't go over it today. And you're right. It's not fair.